Now, a special type of type guard, you could say, or something that helps you with type guards, is the discriminated union. Now, what's that? It's a pattern which you can use when working with union types that makes implementing type guards easier. It is available when you work with object types. Let me show you how it works. Let's say we have a couple of interfaces, and this could be classes as well, but here I'll go for interfaces to show that it works with those as well. And there I have my bird, which has a flying speed, which should be of type number, let's say. And I also have my horse, which has a ground speed or a running speed, which should be of type number. So we have these two interfaces here. Now we create our own union type, animal, which is either a bird or a horse. And just as before, we might have a function, move animal, that takes an animal as an input, which is of type animal, so using our union type. And now in there, I want to say moving with speed. And now, of course, I need to access either flying speed or running speed. Now, of course, we could have just named it speed. But this is just a simplified example of a real use case you might face, where you have some interfaces or objects in general that are kind of related but have different properties or methods. So here it's the speed property, which actually is different. So I can't access flying speed here because, of course, not all animals have a flying speed. Now we can do what we learned before. We can check if flying speed is in animal here. And if that is the case, we can execute this code. Now, this is an approach we can take, but the more potential animals we get there, the more things we have to check. We also can mistype here in this string. We can forget an E, for example, and wonder why this won't work. Now, we can't use instance of here because I'm working with interfaces. As I explained, animal instance of bird will not work because that is an interface which is not compiled to JavaScript. So at runtime, this will not be available as a constructor function. So therefore, this does not work. Now we can build a discriminated union here by giving every interface, so every object which should be part of that union, an extra property. You can use any name you want. Often you use kind or type here. I'll go for type and name this bird. Now important, we're creating an interface here. So this is actually not a value for the type property. This instead is a literal type, as you learned, where type must hold a string which must be bird. So this is a type assignment where we narrow down the value that may be stored in type to exactly this string value. And I do the same for horse, just with horse as a literal type. Now here in our function, we can use a switch statement and switch on animal.type. Every animal has a type property because we added it to all interfaces that make up our animal. And then here we can have a couple of cases where we even get auto-completion because TypeScript and our IDE understands that type can only either be bird or horse. And if it's bird, then we could set some internal variable speed to, let's say, animal.flying speed, and then break thereafter. Otherwise, if the case is horse, we set speed equal to animal.running speed. And thereafter, we can console log moving at speed plus speed. And if I now call move animal with an animal I create on the fly here, where I set the type to bird, and I'm only allowed to use bird or horse, then I have to set my flying speed. And by the way, TypeScript even recognizes that I can't set running speed here. If I try to do that and set this to 10, it complains that this is not available for type bird. If I set it to flying speed, however, it works. And if we save that, it outputs this correctly and also compiles without errors. Now, this is a discriminated union because we have one common property in every object that makes up our union, which describes that object, so that we can use this property that describes this object in our check to have 100% type safety and understand which properties are available for such an object and which properties are not. So this is another useful pattern which you can use when working with objects and with union types. And it even works with interfaces because this interface forces every object you build based on this interface to have this type. So instead of checking for the existence of a given property, or instead of using instance of, we use a property we know that exists to check which type of object we're working with. We also eliminate the danger of mistyping because TypeScript understands that the only cases we can have here for animal type are bird and horse, and hence it gives us this autocompletion, and if we would introduce a typo, we would immediately get an error. So therefore, this is a very useful pattern when working with objects and union types.